Okay, we're going to talk about naming alkanes. So alkanes are hydrocarbons, and when we usually name covalent compounds, we use molecular formula to describe the compound. This doesn't work for many hydrocarbons because lots of hydrocarbons will have the same molecular formula but different structural formula. So let's have a look at an example of this. Here we have an organic molecule, a hydrocarbon, with 4 carbons and 10 hydrogens. And here we have another organic molecule with 4 carbons and 10 hydrogens. So they have the same molecular formula, but these are quite clearly different molecules. And importantly, they have different physical and chemical properties. So we need a way of describing these two molecules that describes their molecular formula and their structure at the same time. So a bunch of clever chemists have come up with the IUPAC system, which is the naming system we use for all organic compounds. It's very simple and it can be used following simple steps. You get the hang of it pretty quickly, and it can be used to describe a whole range of organic compounds, including alkanes, alkenes, cycloalkanes and benzenes, which is what you're going to be studying this year. So the system uses prefixes, stems, and suffixes to describe the molecular formula and the structure of organic compounds. So let's talk about how to use the IUPAC system to name unbranched alkanes to start with. The first thing is the suffix, so that's the ending of the word, and when we're talking about alkanes, or saturated hydrocarbons, those that don't contain any double bonds, we use the ending "ane" to describe it. So if you see only single bonds, like in this molecule here between the carbons, you know it's an alkane and you're going to have an "ane" ending. After that, we try to find the number of carbons in the continuous unbranched chain, and we assign a stem from the table below. So if we look at this molecule here, we have 1, 2, 3, 4 carbons in a row, so we would assign the stem but to this, so we would call this butane. If there are any substituents, like halides, we describe this using appropriate prefixes, so those go before the stem. So prefixes would be things like fluoro, chloro, bromo, and iodo. And we also give a number to give the position of the substituent on the carbon chain. So that will make sense when we do an example. So here are 2 examples here. The first one we've already talked about. Butane has no double bonds, so we know it's a alkane. So it has an "ane" ending and it has 1, 2, 3, 4 carbons in it, so it gets the prefix or the stem but, so butane. The next one we're going to talk about is here. We have 1, 2, 3, 4 carbons again, so we know it's but. We can't see any double bonds, so we know it's ane because it's an alkane. But then we have to describe this substituent here. So it's chlorine, so we're going to call it chloro, and it's on the second carbon in the carbon chain, so it's 2-chlorobutane. So before we do these examples, these are the same examples you have in your PowerPoints. I'd like you to stop the recording, complete the examples yourself, and then see if you get it correct. Okay, so the first carbon we have here is an unbranched alkane, and all we have to do is look at it, make sure it has no double bonds, say it's an alkane, so it has an "ane" ending, and then count the number of carbons. 1, 2, 3, 4, 5, 6, 7. So if we look back at our prefix table, we see that 7 is hept. So this example here is simply heptane. Heptane. So the next example, same thing, look at the carbons, there are no double bonds between carbons, so it's an alkane. And we need to count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 carbons, and so if we look at our table, we would find that the stem for 10 is dec, so that's decane. So we can just name that decane now. And then if we look at this next one, it's drawn slightly differently, and we'll just describe that. So when we draw large organic compounds, we draw a lot of carbons, and they get sick of drawing carbons basically. So what they do is where any two lines meet, unless specified otherwise, that connection is a carbon atom. So if we were to count the number of carbons in this molecule, it is 1, 2, 3, 4, 5, 6, 7, 8 carbons in total. So that is octane. So it's oct. We know it's an alkane because there are no double bonds. So it's octane. And we have to describe the position of this fluorine substituent. So it might feel tempting to say 1, 2, 3, 4, 5, 6 carbons in. There's a fluorine, so 6-fluorooctane. However, that would be incorrect because we like to give it the lowest possible number. And if we count from this end, 1, 2, 3, that's a lower number than 6, and it still describes the molecule exactly. So this would be 3-fluorooctane. Okay, let's talk about something a little bit more complicated, and that is branched alkanes. So the same rules apply. We give the suffix of ane if it is a alkane. We count the number of carbons in the largest carbon chain, and then we assign a stem. Now, what's important here is that this will not always look like a linear chain in the picture, and you'll see what I mean soon. Any of the alkane branches, so side branches, are called alkyl groups, and they're given the suffix -ul. These are numbered using the stem names, so things like meth, eth, prop, etc. Now, the alkyl group position on the chain is denoted by a number followed by a hyphen before the alkyl group. So just like we did with the substituents on an unbranched alkane. If two of the same alkyl groups are present, a prefix is added, e.g. 2,3-dimethyl, to describe the number of alkyl groups there. So if there were 3, it would be trimethyl. Okay, so here's an example. We have 1, 2, 3 is our longest carbon chain. So this is propane. And then we have a single carbon coming off. If we look at our stem table, a single carbon is meth, so that is methyl, and we need to describe the carbon that's coming off, so it's the 1, 2 second carbon, so that is 2-methyl propane. Let's look at some other examples now. So that's the example that we just did, 2-methyl propane. Can you see how they're the same? But the rest of them are different. So I'm going to give you a moment now to stop the recording, complete them yourself, and then see if you were correct. Okay, so let's do the next one. So if we count the longest chain here, it is 1, 2, 3, 4. Can you see how it's not a linear chain? It actually bends around. 1, 2, 3, 4 carbons. So this is bute. We know that there are no double bonds, so it's butane. And we need to describe the position of this substituent or this methyl group. So it's 1, 2, 3, 4, and it's on the second carbon. So this would be 2-methyl, because it's a substituent that is an alkane, so it's an ul ending. So that's 2-methyl butane. Okay, we're getting some more complicated ones. So once again, for this one here, we need to count the longest continuous carbon chain. So it might be tempting to go linear across the page, 1, 2, 3, 4, 5, 6, 7, and then have a propyl substituent and a methyl substituent. But if we count like this, 1, 2, 3, 4, 5, 6, 7, 8, we can actually see that the longest carbon chain has 8, so it's an octane. And then we will simply have two substituent alkyl groups coming off. The first one is at position 1, 2, 3, and that is a methyl group because it has a single CH3. And the other one is an ethyl group, and that's coming off at position 1, 2, 3, 4, 5. This is an ethyl group because it contains 2 carbons, an alkyl with 2 carbons. So the name of this will be 5-ethyl 3-methyl octane, because it has a main chain with 8 carbons in it. The last example we're going to do here, we have to count the longest carbon chain, which is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons long. So if we look at our STEM table, 10 will be dec, so that's decane. And then if we count the number of carbons in, 1, 2, 3, 4, 5, there are 2 substituents coming off the 5th carbon in the chain, a methyl group and an ethyl group. So this will be 5-ethyl 5-methyl decane. Can you notice how in these 2 examples, I've named the ethyl group before the methyl group? This is a IUPAC standard procedure. When you've got an ethyl group, because it's larger, it comes before the methyl group when naming the compound. Even if the methyl group is on a carbon before the ethyl group is still named before it. So if there was a propyl group or 3 carbons coming off the main chain, then that would go before the ethyl.